Okay, we're going to get started, and again, welcome to folks who have just recently joined the webcast. And I'm very excited to bring to you today the educators from Binghamton University and Minneapolis College of Art and Design, MCAD, who have been teaching with Sustainable Minds and really creating incredible results, and I'm thrilled that they're able to take the time to share their stories with us today. Just a minute of housekeeping. We'll take questions between each of the schools' presentations, and at the end we'll have time for group discussion as well as Q&A, but send in your questions anytime you have one, and we'll keep them in the queue and take them as they are timely. So, moving forward, when we talk about creating knowledge workers for the greener product marketplace, what we really believe is that teaching environmental sustainability in higher education is really about creating jobs for the new economy, and that schools who are integrating environmental sustainability into curriculum will increasingly attract more and better students, and manufacturers who ultimately want to compete in the greener product marketplace are going to recruit students out of your schools. It's about training students to get out of school, on the job, and bring valuable skills that create value for themselves and for the companies that they're working for. So today we'll be showcasing faculty teaching in sustainable design and engineering programs. And there's so many of these evolving all around the world, and I should tell you that we have an international audience today, which is really thrilling. We actually have quite a few schools outside of North America using Sustainable Minds, and some of those schools are here in attendance listening today. So the agenda for today is an introduction to Sustainable Minds and a tutorial on eco-design, LCA, and how the software works, to create some context then for the presentations that the educators will give, both from Binghamton and MCAD, and then we'll move into the discussion at the end. So Sustainable Minds is a cloud software and services company, in that order. We're a software company, and our services are to support the training and transfer of knowledge to educators and industry to integrate environmental sustainability into the way they make products. So our mission as a company is to operationalize environmental performance into mainstream product development and manufacturing. And we're doing that by bringing together two fields of practice and of science. So eco-design and life cycle assessment. And eco-design being a life cycle approach to product development, applying new strategies in each stage of the product's life cycle, and life cycle assessment, the scientific method for measuring the relative value, the relative greenness of products and systems. And when you put new ideas and thinking differently together with metrics and measurement, you're going to get some truly greener products. And it's really in the thinking differently that the innovation starts, but the metrics and the measurement provide a vehicle for evaluating those new ways of thinking to determine whether those new ideas are going to truly make a difference or not. And oftentimes it's the measurement that provides the insights into new ideas to explore. So like any other kind of design process, it's iterative. Design, measure, until you've either answered the questions you've set out to solve or your client or customer says it's done. Just a quick background on eco-design and LCA. Here we show a very simplified eco-design strategy wheel that maps very high-level strategies to the stages of the product's life cycle, from manufacturing to distribution, use, and end of life. And drilling down into each of those life cycle stages, we actually put a stage on the front end before any thought is even given to the artifact, a stage considering innovation, rethinking how to provide the benefit. Not every new product should be a recreation or an iteration of the existing product, and we're going to see some new thinking on exactly that issue in some of the work we'll see later. And exploring other strategies in each stage of the product's life cycle that haven't necessarily been considered before separately or together, different strategies from multiple stages. And life cycle assessment, a quick background for those not familiar, is recognized and codified through ISO. There's an extensive series, and again, it's an objective and comprehensive method for quantifying the relative greenness of products or systems. And there's a very standardized approach. You start by setting the scope and goal for the assessment. What do you hope to learn? What's going to be included? Building the inventory, so building the model of the system that will be evaluated, and then assessing the impacts of that system and iterating and interpreting. Sustainable Minds is built on this model. Everything about Sustainable Minds is ISO compliant, but you can see that life cycle assessment itself is designed as an iterative process. In Sustainable Minds, we've integrated both life cycle assessment terminology with manufacturing terminology. And so instead of looking only at a bill of materials in life cycle assessment, we're looking at all of the inputs across the life cycle of the product. So we've coined this term called system bill of materials. So all of the inputs that go into a product across its life cycle are made up of chemicals, and in life cycle assessment terminology, this is known as process inventory data, which is simply chemical data. And all of these chemicals, when put through the lens of a methodology, can be attributed to one or more categories of impact, and each of these impact categories can be attributed to one or more types of damage, either to human health or to the built environment. The way we've made life cycle assessment simplified and understandable to non-life cycle scientists is to create a single figure scoring system, which is also known as a screening LCA, where we look at the impacts from each of those chemicals to these 10 impact categories, and rather than expressing them in 10 individual numeric results, we normalize and weight those results into a single figure score. So it's a relative value. The higher the score, the greater the impact. The lower the score, the lesser the impact. And we pull out the global warming score and also provide that in terms of carbon equivalence so that you can do carbon footprinting. So moving forward, talking about how product development has changed in organizations today, there are so many more people involved in making decisions about products and what to make. And if you look at this list of participants, you can see that these people represent every discipline, from business through design and engineering, which really creates the setup for looking at the kinds of organizations using Sustainable Minds. Our focus is certainly on manufacturers, but moving into education, you can see that not only do we have schools using Sustainable Minds from all around the world, they represent every discipline as required in business to make products. We have Sustainable Minds being used by educators teaching business design and every kind of engineering, chemical, mechanical, civil, environmental, both in undergraduate and graduate programs, continuing education, online learning. And today you're going to see some examples of really some very innovative delivery of education, both in traditional university and in an online master's degree program. So we talk about environmental performance, don't talk about sustainability. Environmental performance is really just the next criteria in product development that sits alongside all of the other criteria like functional performance, cost, aesthetics, safety. And now as product teams are making decisions about what to make and how to make them, they have to factor in environmental performance, and they need data to be able to make informed and credible decisions in the earliest stages of product development. Sustainable Minds is really a business analytics application, and again you're going to see that borne out in the examples that the educators show you today. We're all going to tell you that there's no such thing as a green product. Green is a relative value, and it's all about comparisons. So Sustainable Minds is really just a comparison engine, if you will, that allows the users to create a reference or a benchmark, evaluate it, and then generate as many more solutions or concepts as they like to compare how making changes informed by different eco-design strategies can improve or not improve the environmental performance of the product concept. So Sustainable Minds is actually eco-concept modeling software with real-time LCA-based results. We're based on 3 pillars: software, data, collaboration, learning and knowledge management, and community. And that's ultimately how we'll achieve our mission and how this knowledge will transfer and scale. This is a quick view of part of our learning center, just to show you that we have an extensive amount of content for on-the-job training or to integrate into curriculum. This is, for example, simply one screen from the user's guide, but the Learning Center is about 100 to 150 page equivalent to a textbook on eco-design and LCA. But at the end of the day, even if you read nothing, it's real easy to use, and it allows you to benchmark and compare product concepts, model with any data that you need. Because we're in the cloud, you can use the data that we already have in the system, or we can work with you to add data from your supply chain or from primary manufacturing, and that's available both to schools as well as industry. It's easy to see the data that we have, so you can determine what you might need and request. And just a few screenshots. You can model as much of the product system as you like, as explicitly as you like. You can experiment with modeling by part or input, or by rolling up all of the materials from each of the parts and enter aggregate weight information. Really, it's as flexible as you need it to be based on what it is you'd like to learn. That said, I'd like to hand it over now to Ken McLeod and Sri Konaru from Binghamton University to tell you about how they have developed their Introduction to Sustainable Engineering and Design course, what they're teaching, and what the students and they themselves are learning. So Ken, take it away.
Okay, very good. Good afternoon, everybody. I'm Ken McLeod, Professor of Bioengineering here at Binghamton University in the Watson School of Engineering and Applied Science. Sri, who is online as well, was teaching assistant for this course we're going to be talking about, And Shri, do you want to say hello?
Yes, hello everyone. Good afternoon. As Dr. McLeod pointed out, I'm his teaching assistant for the course.
Very good. Okay, so my background, I'm an engineer by training, electrical engineer by training. My research here at Binghamton University is a research-oriented university. My work is in chronic health conditions. I do a lot of product development in the world of diagnostics and intervention focused on such chronic conditions. Chronic conditions would include everything from obesity to Alzheimer's, diabetes, osteoporosis, things that are not diseases per se, but what we'd call chronic health conditions. As part of that research, I've been involved in some 12 startup ventures, and most of my work here at the university is focused on teaching innovation and entrepreneurship. And this year I was asked to teach a course in a new sequence we have. It's a minor in sustainable engineering. I had not done this before, but in delving into sustainable product development, it became very clear, as Terry pointed out in the introduction, of this critical first step of concept development, what we always do in entrepreneurship and innovating new products, is a critical step in sustainable engineering. And so if you remember back to that pinwheel she had, and step one was conceptual design and innovation, that's really where, that's the focus of my world. And this is what I've tried to translate from my teaching in entrepreneurship to my teaching in sustainable product development. So in entrepreneurship, we're focused on issues like defining the user experience. That is to say, we're moving away from thinking about product design and thinking about the design of user experiences, and I've tried to translate that over to this course. We're focused strongly on participatory design and evolutionary design, the whole ship-fix concept. And so these are concepts I've tried to incorporate into this new course. I'll let Shri introduce himself as well.
All right, thank you. Yes, I'm here. So, hello everyone. I'm Sri Koneru. As I introduced myself earlier, I'm the teaching assistant for this course. My background in my undergrad has been the program of bioengineering at Binghamton University. And I've had a strong complex systems emphasis, which I believe ties in nicely to the concept of sustainable engineering. So this has been a really natural course for me. As for my master's, I've completed my master's again at Binghamton University in the program of biomedical engineering. And I've done some chronic pain management research. And now I'm doing my PhD in the same field with a specific focus on pain management. And I'm currently working with Dr. McLeod on device development to help manage such chronic pain conditions. I'm also a TA for this course, and I'll be talking about how I use sustainable minds to help the students learn certain concepts later on in the course. I'll be handing it back to Dr. McLeod now.
Okay, so again, Binghamton is one of the 4 research universities in the SUNY system. We have about some 16,000 students here, the vast majority undergrads. We have probably 2,000 graduate students. The entire Watson School of Engineering is about 2,000 students, grad and undergrad, and we're here in the Department of Bioengineering. A few years back, bioengineering, we have very strong interest among the students in green environmental engineering, and so we initiated a new minor in sustainable engineering. And so this is specifically a program focused on engineering students. So the intent here is not necessarily to introduce engineering concepts, but in fact to introduce the appropriate concepts of sustainable engineering to students who are already developing or enrolled in an engineering major. It's a 5-course sequence to get their minor. We develop 3 core courses, and then we rely on the departments to each of them offer a couple of electives in sustainable engineering that are particular to the majors. Our majors here are bioengineering, as I mentioned, electrical engineering, industrial engineering, mechanical engineering. We also have a computer science major and a computer engineering major. We don't tend to see any students coming into the minor with those backgrounds, so it's more the BE, EE, IE, and ME major. The core And I called it a sequence at one point, and that was really a mistake. It's really a 3-course core. We don't require the students to do it in sequence. The first course we're going to be talking about today is Introduction to Sustainable Engineering and Design, and that is to get the students thinking like a sustainable engineer. There's a course offered out of mechanical engineering on sustainable energy systems, which focuses on alternative energy power sources. And then we have a course that is taught out of environmental systems and geology department on ecological systems, essentially. What is that out there that we're trying to protect from kind of an Earth systems perspective? The program's been in existence for about 3 years. It's ramped up very quickly. The students generally start this in your junior year, finish in their senior year, of course. We have about 150 students in the program, so roughly 75 students or so are entering the program each year. I think if we made it a major, it would probably be the most popular major in the engineering school. What are our goals here? It's essentially, again, to introduce what are the objectives of sustainable engineering. What are we trying to accomplish here? We use Aaron Feld's book, Sustainability by Design, as the primary text. And again, he emphasizes that the goal here is not simply to dramatically reduce our energy and resource usage and make people miserable. It's the opposite. It's how can we make people even happier and more fulfilled than they currently are, and, oh, by the way, at the same time dramatically reduce the resources we're consuming and the energy we're consuming. He is confident this can be done, and actually having taught the course for a semester, I'm in his camp. I really do think it can be done. We take a total cost point of view. That is to say, we're not simply looking at the resources and energy, but how can we reduce the total cost of a product and still deliver the same or better human experience? And so there we're talking about total economic costs and total environmental costs, and not surprisingly we use sustainable minds to allow our students to calculate those environmental costs and rely on the market to provide us value on the economic cost of a particular user experience. And as you well know, while that might factor in certain resources, it ignores, in American society at least, all the externalities. None of those are factored into the price of a product. In the U.S., might be in other countries that some of that is factored in, but certainly not here. The challenge I give the students as project-oriented class is to identify a user experience, a human experience, and remove 80% of the total resources required to achieve that experience out of the cost of that experience. So that's the challenge we give to each of them. This semester we have about 70 students in it, and we put together teams of roughly 3 or 4 to undertake that design project. There we go. This is a typical project. The students, in fact, this semester are just in the process of presenting the work they have done based on what we've taught them over the semester. And this is an example of one of those projects, and I'm going to let Shri, who has worked closely with all of the student teams in applying sustainable minds, to walk you through this project. So go ahead, Shri.
Okay, thank you, Ken. All right, so one of the student projects that they'd like to discuss was the morning coffee experience. They wanted to define what the morning coffee meant to most people, and after interviewing various people, their friends, their colleagues, and other people, they decided that most people drink it for its caffeine, for the kick that they get when they drink that coffee. So they specifically wanted to focus on that and calculate what the typical cost would be for someone who drinks coffee, for a white-collar worker. And they calculated that the total economic cost, which is important in engineering, would be about $9 for a typical coffee drinker when they drank about 2 cups of coffee a day at home. This is using a standard coffee machine that I'll be discussing a little later. And also they looked at the environmental impact with this particular method of coffee drinking, which there's a lot of it involved with the growth, the roasting of it, and shipping it to the U.S. As you can imagine, it's very resource intensive. And now the challenge for them was how they could take out greater than 75% of the costs the resources, the energy, total everything out of the experience, while enhancing the experience for the users. That is, how can they provide the same or better experience but take out the majority of the resources? And the results, the way they showed their economic cost calculations to us was they broke it down with, a coffee brewing machine like the Keurig machine, which uses 1 cup of the powder to produce 1 cup of coffee. And they calculated that they'd get about $9, as I said. And then the alternative solution they suggested was to use a contact lens. Now, there's medicated contact lenses available in the market in which the solution that they're used, you can put whatever various medications or anything else that you wish to. The student suggested that by introducing caffeine in the solution, the user would be able to get the same caffeine kick over a duration throughout the day without the whole process of using all these procedures of brewing it and getting the coffee machine and everything else. An important thing we'd like to teach the students and they used was that time is a very valuable thing as part of the experience. And if you save someone's time, for example, who's making $50 an hour, that's a big savings that they'll get by taking out the time. So as you can see here, there's an 82% economic savings by switching over to this innovative method. Now, just a couple of screenshots from the way they calculated the environmental costs for both of them. This is the bill of materials, and as you can see, they've broken it down nicely into how they constructed the coffee machine. This is the manufacturing part, and they got a total Ocala score per use, which they used. And another slide was, this is their contact lens solution, and here they discussed the end of life for such a method because it's important to think about what happens when you throw away a product or recycle it. It's not just about the manufacturing or use, it's the total cost. And so here they decided to send some of it to recycling and some of it to the landfill, and this is the total cost they got just for the end of life. And when they added up everything, they got close to a 99.6% environmental savings as opposed to the coffee cup, the coffee brewing method. As you can imagine, there's so many materials that can be reduced. And so with these two numbers, they told us that on an average there would be at least 80% savings. And so that was a great example of how software helped them to get their cost calculations. Some of the key learnings that I believe the students were able to get from the software was Sustainable Minds is an extremely graphical interface, and it's very easy to learn. And so it helped them quickly ramp up on how to do basic calculations and other things, and it permitted them to rapidly do a number of examples for themselves. And what we like to call this is the back-of-envelope calculations, which means they can do quick estimates between various products and existing designs. For example, their coffee cup method versus the lens, and for example, some 2 or 3 more things that they'd like to discuss. As a TA myself, and I think Dr. McLeod will agree with me on this too, is I think it enhances the learning experience for students instead of just text and reading it. I think from experience, we know that students love to do examples in class, and I think this lets them do just that. As for the future, I think as designers, it'll help them evaluate environmental impacts for whatever it is they're designing, the user experiences or the products when they work for companies. It'll really help them think about all these aspects as future designers and the next generation. So I think that's my key learnings from this course, and I think Dr. McLeod will help us with the trends as he sees in the industry.
Yes, again, in this course, we've really focused on this upfront design process, the conceptual design process, and that's because in my experience, and I think most designers will tell you this, that 80% of the costs are factored in those initial conceptual design decisions, and it's very hard to do, to optimize, dramatically reduce costs once you've exited that conceptual design stage. So we have focused it on here, and this, as Sri pointed out, a very nice way to make rapid calculations. Are we in the ballpark? Are we accomplishing what we're trying to accomplish here? And so it's worked out well there for us. I think this is something that can serve all students, at least all students in engineering well. One of the things in terms of industry trends, where are things going, Is this on the top of their minds? I mean, I think that it's certainly getting good coverage. I mean, I see the coal industry now advertise itself as a green industry, green coal. So you can get some press out of it. How much it's actually being factored into products at this stage and opportunities for designers with this background is not yet clear to me. But what's certainly clear is that there is a need for people who have a conceptual understanding of this. That is to say, I see many of our students perhaps moving into positions where they're either making policy decisions or they're advising policymakers on certain decisions. And in that case, this understanding of how does one quickly demonstrate that, as Terry was saying right on, there isn't one way to do this. There's half a dozen ways to do this, and we can do this in a much greener way. So the ability to quickly come up with plausible alternatives, I think, will serve them well in their careers. And corresponding, having gone through the course, they have, with 70 students, we have some 20. I think we have 21 groups this semester. They have 21 examples of how the world can be a much greener, much more resourceful place, and I think that will serve them well as they move through their careers over the coming years and decades. So I think it's been a good experience for the students on a number of fronts. Terry, back to you.
I think there's one more we have to discuss in the trends. That's the next slide. What the industry can take away about the importance of this.
Oh, and I think I just kind of merged these in. But I was intrigued by yesterday. I was reading the New York Times, and the auto show in Detroit is ramping up, and they were interviewing one of the Ford designers, and the Ford designer says, "You're looking this as a truck, but I don't view this truck as a truck. I view this truck as a mobile office because most of the people purchasing our trucks, in fact, are contractors, and this is their office. So what we are designing is an office that also happens to be mobile." And I thought it was a wonderful example of how to think about the user experience and design for the user experience. It really took me aback when he was saying that, but that's truly where design is going. And so, this ability to think this way, think in terms of doing things in a different way rather than simply optimizing, doing things in a better way, is going to be very important to this next generation of young engineers and designers.
Well, thank you,
Ken.
Shri.
I forgot about that slide.
Yeah. Thank you, Ken and Shri. And actually, I heard a story about that same truck on NPR, which was very, very interesting. So we're going to move forward, and again, participants who are listening in, if you have questions, type them in. We'll take them as they come. And I think the questions that we received so far are good questions to have discussion at the end. So I'm going to move right into introducing our educators teaching at Minneapolis College of Art and Design. And we're thrilled, actually, that MCAD is using sustainable lines in 3 courses. And today we have 3 of those faculty to discuss their courses. And I'm going to turn it over to Kurt McNamara to tell us a little bit about the school, and then talk about his course, and we'll go on to Arlene Burt and then Jer Faluti.
Hi guys. So I'm Kurt, and I'll just talk a little bit about the program in general and about my foundational course. So the course I'll talk about is called Systems Thinking, a requirement for everybody in the course in their first year. Arlene will talk about a course called Life Cycles, and then Jeremy will talk about collaborative product design. So these courses are all part of what we know is the first online master's degree in sustainable design. At MCAD, it's one of the only 2 full grad programs we offer. It's got a variety of students in it. They come from outside the institution as well as inside. We have a fair amount of practicing designers, and my current students include some from Australia, some from Germany, Colorado, California, 2 from Brooklyn, so pretty good mix. We're set up to work, essentially for people who already have a job, by and large, and can fit this program in and around it, although we have some full-time students too. And let's see here. And I think I already mentioned that. We don't teach engineers. We have a lot of kinds of designers, graphic designers, industrial, fashion, packaging, marketers, that sort of thing. And then this is me. And a little bit about me is that I'm a design engineer with a bunch of years of experience. Besides this course, I teach Innovation Tools and Techniques, another foundational course, and a course on Bucky Fuller called Design for Sustainability. And then one of my research interests is that I'm also a biomercury educator, and I'm interested in connecting life's principles, which are more qualitative view of the impact of a design, with life cycle analysis, which of course is kind of the only quantitative way to get an idea of the design impact. So this course is for our first-year students. The program is a 2-year program. We have a new cadre entering every year, about 16-ish, maybe a few more. We do a pretty quick survey of all kinds of approaches to sustainability from a systems perspective. They learn about systems in general. They learn about boundaries and functions and supersystem and subsystem and ways to examine things. And the LCA is only 1 week, and so we really throw them into this thing. So here's a typical student project, and Amy Dritz, who's one of our students, basically took apart her floss and said, what's in this thing? I should say that we, by and large, have students do a take-apart exercise. They seem to really like it. They get into it. Of course, we're guessing at some materials. That's okay. They do look at all the phases of the product when they do this. And so this one is notable because she took the data back from Sustainable Minds and combined it in an interesting way to show the total impacts of manufacturing, total impacts of transportation, the use basically, and then the end of life of the landfill. And this shows one of the learnings that we come up with often in the class is that somebody says, well, what if I drove my car to the store to buy this? And it turns out that the life cycle impact of driving a car to get a single thing dwarfs everything else. And so if you look at the details here, this 0.5 millipoint almost entirely comes from driving a car to get this thing. So that's one of the learnings that students get, and that's fine. It's a good lesson for us. Another one, Sarah Dellinger took apart an iron, and this is not uncommon as well. Take apart a kitchen appliance, we tell them, or a household appliance. If you don't have something, go to a thrift store, take it apart. We talk about, what goes in things like the power cable, there's copper in there, and then there's some kind of insulation, that sort of stuff. And then Sarah went through and did this analysis, and here's another learning we get, which is that on the left side, if you dispose of it correctly, on the left side, if you dispose of it incorrectly, you get a very high life cycle impact. You see here 1,000 millipoints per hour of use. And what happened here is it landed in the incinerator. And in the incinerator, the copper, as well as the other metals, basically got emitted. And unfortunately, if you're in Minneapolis and you throw some in the garbage, it goes in the incinerator. On the right side, if you dispose of it correctly, then the life cycle impact goes way down. You can see here that it's just a fraction of a millipoint. Another learning that students often get. And now a very detailed one from Stephanie Kohler, and she really dug into this Bic lighter and looked at all the details of it. And this is an example of looking for the largest impact in a single design, and she was able to identify that the plastic body has the greatest impact in this particular case. So that's one of the ways we often see the LCAs completed in this 1 week intensive, is that they look at a single product, not an alternative design, and just say, what's the biggest impact? And then finally, this is from Evelyn Hussain, who's one of our designers from Hong Kong, who's looked at a toothbrush in great amount of detail, and then she said, what if we made this from PLA instead of polypropylene? What are the impacts here? So she's able to easily look within the tool and able to compare and look at the impacts of it. So you can see, even though this is a very whirlwind tour through LCA, The students got quite a bit out of it. They learned how easy it was to use it. They've got their feet wet in it. They're ready for Arlene's class or Jeremy's class. I would say, I'll mention that in the past we used more spreadsheet type of approaches to it, and that was much more challenging for the students. Having the web interface has been a lot easier for them to navigate, and we actually made a short YouTube video to actually guide them through it as well. So let's see. There we go. So we already discussed sort of, one of the student learnings is, largest impact can be the transport or the end of life and the material choice. For us, how easy it is essentially to get students in there learning LCA. There's some, intense stuff during the week as they find things out and don't find things out. A lot of emails go back and forth, and so they need to be online a lot, but they all get through it. And then we also see, this allows the students to have sort of a portfolio piece, explain they know something. People understand that they can do this as a what-if very early in the design process. And it is, like I said, really the only system sort of quantifies the results. Two other findings that have come more out of working with Arlene for the life cycles class is that, and we don't go into this so much in the systems thinking class because it's kind of advanced, but defining the function and functional unit is challenging. And so in Arlene's class, there's a whole week where we talk about that, what that means and how to figure it out, and that sort of thing. And it's really a critical thing, and it's easy to get kind of sidetracked or miss the details of it. And then, really defining the system boundary and where we draw the line is really critical as well. So I think that might be it for me. Yep.
Great. Thanks, Kurt. This is Arlene here. Before I talk about the course that I co-developed with Kurt, which is called Life Cycles, I'll tell you a little bit about my own background. I'm adjunct faculty at MCAD, as well as the work I do is what I like to refer to it as visual storytelling. It's kind of this idea of combining information design with sustainability communication. I did a Fulbright grant that looked at communicating product backgrounds and life cycles, which has led into a lot of the work that I'm doing today. So Life Cycles course is one I co-developed with Kurt, and it follows Kurt's course on systems thinking. Also, there's a prereq of some basic sustainability courses. This course is an elective. It's not necessarily required for the MA. We have a wide range of students, as Kurt mentioned before. Most of those I'm finding have a visual background, and especially because this particular course combines a more in-depth look at life cycles, including life cycle analysis, for which we use Sustainable Minds, and also the idea of communicating these cycles through information design and data visualization techniques. So I'm going to walk through some examples of different student work that would take you through the steps of the course that we go through. First, we start off some basic understanding of what a life cycle is. So we have students explore both in terms of life cycle analysis as well as general life cycles that exist in science and in the world. Then we have them select one product that they use throughout the entire semester. This particular student selected the packaging for tea, and they dissect that product, they weigh all the individual components, they map out the order of these components, the processes it goes through. This is what you see here is a material summary where the student is starting to pull out specific points that would help lower the impact throughout from areas of the life cycle of this product. And this course is really about the communication of the data that we can get from a tool like Sustainable Minds. So another student here, you can see how they dissected their product. This was a kind of a toy, a small plastic toy, and then they mapped out the impacts of that throughout each phase, so you can at a glance quickly understand where the impacts occurred. Another format that the student was looking at in eyeshadow compact. This shows two different methods of showing where the impact occurs throughout the life cycle of that product and in what impact categories. And this student was looking at a bag. He broke down the different components of the bag and found that in the end the transportation was by far the largest impact. And a lot of the exercises we do in this course are really about communicating the story behind these. So I think this is a good example to show how, using this life cycle data, the student was trying to tell the story in a way that consumers and kind of people not necessarily familiar with life cycle analysis could grasp the data that was being provided. So overall, some learnings from the course and the development of the course. Students learn about life cycles. They also get to understand this method of quantifying sustainability in more depth. They also learn how to communicate this in an engaging visual way through information design. What we found through teaching this course is that the Sustainable Minds is easy to use. It doesn't take a ton of orientation to get students into it. And it also, what's great for the visual side of this course is that it gives students real data to work with on a single product that they've followed all the way through the duration of the course. So with that, I'll hand it off to Jeremy.
All right, thanks. So yeah, I also teach at MCAD as well as some other places as well, such as, well, I guess it says on the next slide here. Trying to navigate back. There we go. So yeah, so I've taught at MCAD for a few years. I've also taught in the engineering design department at Stanford and other sort of more standard art school design schools like Emily Carr in Vancouver and California College of the Arts. And I also try to help propagate sustainable design ideas through writing as well. I've contributed to various books on the subject and have also tried to help create sustainability-related tools. Like I did a project with the Biomimicry Institute called asknature.org. I did the prototype of it, and it's basically an online database of biomimicry for people that like the idea of biomimicry but don't know that much about nature. And it's great for students, by the way. And also a website called streetnaturescore.org that I put together to help encourage urban nature. And what I do at MCAD is a class called Collaborative Product Design, where I get students together in small groups and they do sustainable redesigns of real products for real companies. So this has included some big companies like HP and Steelcase and Panasonic, Motorola. Not all of these have been at MCAD. Some of them have been at other schools that I teach at. And then some smaller companies as well that you might not have heard of, like Luidia, People Power, Oboes, smaller startups doing different kinds of products. And I generally structure the course around a green design method that I made up a couple years ago, which you can see on the Autodesk Sustainability Workshop, which is sort of an online textbook of how to do green design using largely videos, but also some written material and PDFs as well. And yeah, and I highly recommend it for use in classes that you teach. That's what we designed it for, was to be able to be a teaching resource in classes. And so this design method that I use for this class is called the Whole Systems and Lifecycle Design Method. And as you might guess, it uses LCA or potentially other quantitative analysis tools as a central part of the design method. So I'll give you guys an example of the system, of the method. So here's a product that was done by a couple students last year. It was by Myrna Gaza and Elke Erschfeld. And so what they did, they were doing a project for Panasonic, redesigning this web camera. So sort of a security camera that is web-based, and you see the results on your computer. And the first step in the whole systems and life cycle thinking method is to map out the whole system. I'm not going to show that map here, but basically you try to consider all of the different parts of the product life cycle. And then once you have that, so all the different components of the camera plus all the other parts that this camera connects to. So the computer that reads out its video, the wall that you hang this thing on, all the other stuff in the system that this camera lives in. And then what you do is, once you have that system mapped out, you do an LCA of it. And I use Sustainable Minds for the class just because it's by far the simplest LCA tool interface-wise that is out there, and that still gives good results, basically, good analysis. So this is their LCA of the camera, and the top graph is the total impacts, and the bottom graph is CO2 emissions. And in both cases, by far the dominant impact was from the energy use during the camera's life. And so what this does in the green design method is gives the students their top priority for redesign. So they know that, that yes, having greener electronics is also a nice thing. That was the second priority, but by far the biggest priority is the energy use during the life. And so all their ideas should really be oriented towards that. And so that becomes their design brief, basically, and keeping in mind cost concerns and usability concerns, but with their top priority being to fix the energy use during its life. So then they did a bunch of brainstorming, and we'll see this, there we go, on the next slide. So they had way more ideas than this. This is the top 9 ideas that they sort of weeded out after a while. If we can go back to it, there you go. I'm not going to talk about all of these, but basically some sort of fun ones are in the upper left, an exercise-powered webcam, so that instead of using grid electricity, which in the U.S. is largely coal, or at least half coal power, which is why electricity has such a big impact, you can use clean power by generating your own. Or the upper middle one is using solar panels for the power. Then some of the other ones are redesigns of the camera that don't use motors. So in the original camera, there are 2 motors that move around the camera so that it can point in different directions. And the students estimated that was actually a big chunk of the energy use of the camera, pretty much that and the CCDs. So they came up with these ideas, actually a few different variations of this idea of having a compound eye, so that there is no need for a motor. Instead, you have a bunch of little versions of the camera that can see in all directions at once, or potentially just a bunch of different lenses that all feed into the same sensor, again, so that you can see all around at once. And a final one in the lower right-hand corner is an idea of kinetic energy door hinges. So again, trying to generate your own clean electricity, but in this case, using the hinge of whatever doorway this camera would be sitting above, because that was one of the most common uses for a security camera, is to monitor people coming and going over a doorway. So once you have all these ideas that you've come up with your brainstorming, you then do an LCA of all of the top ideas so that you can compare them and basically see which one is the winner. And so that is in the next slide here. So this is an LCA. You can see the top graph is one that they did. This is of the total environmental impacts, and then the bottom graph is just of CO2 impacts. And you can see they have pretty much the same trend, which is reassuring. And the really fat, large bar at the left-hand side is the original product, the sort of base case. And then all the other ones are these 9 scenarios that you saw in the previous page. And you can see that there's a couple of them that don't really improve the environmental impact of the product. In fact, one of them is actually worse than the original. And this is stuff that's really important for the students to know, because it's great to have a bunch of different ideas on how you might improve the design of something, but you really need to know what's actually making things better and what might make things worse, because that is a very real possibility. And then obviously some of these other ones had significant improvements of up to, let's say, 30 or 40% here. And the best one, which is the last scenario here, was that one that we saw at the lower right before, which is the hinge-powered camera. And so in the next slide here, we have, come on, there we go. In the next slide here, we have a more detailed write-up of how that would work, basically. You'd have the camera sitting on top of the door, and it would be connected with a wire to this hinge that would have a little motor inside that would charge up batteries in the camera. And they've got some details written up about it on the right. And so that's basically the process that they use during the class. And that that gives them a lot of great learnings. So for the students, it's largely figuring out what your priorities are for green redesign. And in this particular case, it was lifetime energy use. Obviously, for other products, it's different. And then the second major learning is that LCA is a valuable tool to filter out all these ideas that you have to choose which one is the best by basically choosing which one gives the greatest improvement in impacts. And then their final learning is that thinking with a whole system perspective can cause more radical redesigns, something that wouldn't really talk about right here, but that's another key learning of the class. And then finally, as a teacher, the usefulness of Sustainable Minds is building eco-impact literacy with the students. And then as part of that, number 2, it gives designers more technical analytical skills, which I think are valuable in the job world and I think are valuable for any creative who really wants to make an impact, because then you're not so dependent on engineers or other technical people to tell you when you've done well and when you've done badly, but you can really be more autonomous and really decide more for yourself. And then finally, putting these things together gives you a better design process that gives you both the wide creativity of whole systems thinking and the quantitative rigor of life cycle assessment. So that's basically it for the class that I teach.
Okay, and then overall, what we see at MCAD is that, you know, as Jeremy said, LCA is really a front-end tool. What if? We can look at lots of things, students will look at things easily and see what's what. They can compare strategies. Once again, they can look at collaborative consumption versus individual ownership, end-of-life impacts, impact according to the product, and as well, presenting information in a way that decision makers and consumers can see what's going on. So, and then industry takeaways, for the employers and things the students are telling us, is that they feel confident they can go in and get useful and interesting data. Those are, in the case of our students, still somewhat simple compared to somebody who's done LCA for a lifetime, obviously, but they're insightful and they're meaningful, and that those LCAs can be used to determine the largest life cycle impact and guide the design decisions, and that same information can be used to guide buying decisions in the marketplace, if essentially it can be used to market the product. And I think that's it for MCAD. And it looks like Terry is still muted, so she'll probably come on here in a second and wrap things up for us.
Yep, here I am, I'm back. Thank you so much, Kurt, Arlene, and Jer, and Sri and Craig. What this range of stories, I think, expresses so well is the creativity, really, of the educators integrating life cycle thinking and life cycle assessment into not only a range of different types of curriculum by discipline, but even by level of complexity, from sheer ideation and exploration and benchmarking to information visualization, which is actually a first time we've showcased anything like that. Arlene's class is quite unique. To showcasing the work that Jer is teaching, which is really even more sophisticated than many of the strategists and manufacturers are doing today. And so we're very excited that that educators of this caliber have embraced Sustainable Minds and are really using it to innovate in their curriculum. We were ambitious with our agenda today, having so much content, so I just want to wrap up with just a peek at some pricing. We've tried to make educational pricing quite doable with a student subscription at $79 for a little bit more than a semester, and educators for $350. Our quantity discount programs make it increasingly inexpensive to have more than just a class start to use. We have department packages, we have school site-wide subscriptions, and I wanted to point out that we also offer a professional services package bundled with subscriptions, which can be used for training, custom data creation, curriculum development, however faculty and educators would like to be supported. We also have a curriculum library where educators who have been teaching with Sustainable Minds have contributed their courses and their curriculum to share with others who are just wanting to get started. But I hope what you've seen today is that really it's each individual educator already teaching kind of has the insights and the knowledge and skills to start integrating environmental sustainability and Sustainable Minds into their curriculum. It really is just about getting started. To further encourage you to get started, you can go to our website and sign up for a 15-day free trial at sustainableminds.com. You can purchase individual subscriptions right online, students and educators. You can contact us to talk about the quantity discount programs. You can go to our blog and watch the first 3 parts of this customer series and read the articles. We'll have the replay up of this webcast within the next week or so, and an article writing up the learnings. And so just simply to wrap up, I wanted to come back to our focus on enabling educators to create the knowledge workers of the future who will create the greener product marketplace, and ensure that students in school today will get out to get good paying jobs that will actually make a difference and shape the world that we all want to live in. That brings us to the end of our content, and we have gotten a few questions that I think we'll follow up directly with the folks who asked. I guess I have one question that I'd like to pose to the group, but I'd like to open it up to the educators who presented today, just to see if you have questions for one another or observations that you'd like to make about seeing the work presented this way. That was a surprise attack on the presenters.
Well, this is Ken McLeod. I do like the focus in Minnesota on the whole systems approach. I do think that is a critical part of design and something that doesn't get as much coverage as it should. And certainly be able to incorporate the environmental impacts of a design into early design thinking, whole system design, is a powerful tool and really reinforces for the students, I think, the importance of thinking of whole system. And you bring that part in, I think they get a better concept of what do we mean by the whole system. And because it's too easy to think in terms of, well, yeah, we have to manufacture it and we have to install it and operate it and maintain it. And that's usually as far as people go. So it really gives them a tool to quantify other aspects that historically have been extremely difficult, where we would throw an economic cost on a step, but how do you take it beyond there, where the externalities, where there's no clear economic cost? It gives them a way to quantify those additional steps. So powerful tool there.
Yeah, I agree. And I particularly like, Ken, in your course, that you're having the students calculate the economic costs of the solution alongside the environmental costs. And that's not something that I've seen demonstrated anywhere else yet. And I love that you're doing that in an engineering course. We're increasingly seeing methods and techniques and goals set in different types of curriculum that you wouldn't necessarily anticipate. And what we hope that leads to is more interdisciplinary or interdepartmental course offerings or curriculum development, because that's how people work in the real world. And I know that's challenging in some academic settings, but it's great to see individual educators taking the initiative to broaden their scope. So I'd ask for one final comment or set of comments from the panelists, and any other thoughts anyone would like to contribute or share?
Well, we really appreciate having Sustainable Minds there and the ability for the students to get in and use it and find it quickly, and the work you've done on the interface, because like we've all said, it's really made it easy.
All right. Well, again, thanks to all of you. I'm always thrilled to see the kind of work that is getting done in the world, and as a software developer and a designer, you can't necessarily predict how people are going to take something that you've envisioned to be used a certain way and apply it in so many different ways. So I'm thrilled with the innovation and the change that's being made in the world. So thank you everyone who has stuck it out longer than we had promised you this would take, and we'll be in touch. We'll reach out to each of you, or you can reach back out to us. It'll take a minute. There are a couple survey questions as you exit, and I hope all of you have a great day, and we'll be in touch. Take care.